Alright, so here's my foldable that I just put together. I'm going to go ahead and title the page. This is the left side of page 19. And this is how to solve multi-step equations. Okay, so that's what this foldable is going to help us do. And then over on the right side of page 19, we're going to put some examples. So here's our first example. 5 parentheses 2x plus 3. Zoom all the way in. 5 parentheses 2x plus 3 equals 30 plus 25. Okay, that's our first example. Take a moment and copy it. And now, if you feel like, oh, I know how to do this, I can do this, and I can just use the foldable, you're welcome to pause and try it yourself. I'm going to go through it and do it using the foldable, but always if you want to pause and get ahead of me, that's a great way to push yourself. Okay, so let's start with the foldable. Look at the equation. Are there any grouping symbols like parentheses or brackets? Yes, there are. There are some parentheses here. So I'm going to choose yes. And it says use a distributive property to multiply the number outside the parentheses by every term inside the parentheses. Okay, so that's this. Alright, so I'm going to do 5 times 2 is 10x, 5 times 3 is 15. Okay, and then I'll bring this down. Look at, so next question, right? So now, when I look at the equation, are there any parentheses? No, there's not. So I'm going to go no. Look at each side of the equation. Are there like terms on the left side? Are there like terms on the right side? Okay. Are there like terms on the left side? No. This has an x and this doesn't have an x. So, oops, sorry. This has an x, this doesn't have an x, so they're not like terms. Are there like terms on the right side? 30 and 25? Yes, those are like terms. They're both constants. Neither of them have variables. So that's a yes. Combine like terms on the left side of the equal sign, combine like terms on the right side of the equal sign. Okay, cool. Well, I can't combine like terms on the left side, but I can combine like terms on the right side. Okay, perfect. And honestly, if you went just from this step straight to this step, that's fine too, right? Here on the left side, I did distributive property. On the right side, I combined like terms. I'm showing it as separate steps just to show the thought process, but totally fine if you skip this middle step. All right, next question. Do you have variables on both sides of the equal sign? No, I don't. There's not a variable on the right side, so that's going to be a no. Okay, so move down. Do you have a constant added or subtracted on both sides of the equal sign? I do have a constant on both sides of the equal sign. It's not being added. Let's take a look at what they mean. Choose the constant that is on the same side. Oh, okay, here, look, this is good because this is what my equation kind of looks like. There's like a variable, right, with a constant and then a constant. So good, this is good that I flipped out this tab. Choose the constant that is on the same side as the variable. Okay, so here's the variable. That would be the 15. Undo that constant by adding the opposite to both sides of the equation. Okay, so I'm undoing it, right? Adding the opposite is the same as, like in this case, subtracting, because adding the opposite is adding negative 15. So I'm going to get rid of this 15 by subtracting 15 from both sides. Okay, and so I end up with 10x equals 55 minus 15 is 40. Okay, does your variable have a coefficient other than 1? Yes, my variable has a coefficient of 10, so that's a yes. Undo the coefficient of the variable by doing the opposite operation, multiply or divide. So in this case, I have an equation that looks kind of like this, where something is multiplied, and then I'm going to divide. So, and I can see that, right? Like, you know how to solve this equation. I'm following the directions on the foldable, but this is a one-step equation. You know how to solve this. I have multiplication by 10, so I'm going to divide by 10. Okay, so that's x equals 40 divided by 10 is 4. And then the last thing on the foldable, you should have a simple equation with a variable equals a number. Check your solution by substituting the number in the original equation, right? And here's how you do it. And so, right, so I can look here. So my answer is x equals 4, and I'm going to check it. So the answer is 4, and so the way that I check it, I'm going to come over here and check, is I'm going to substitute, instead of writing x right here, I'm going to put a 4. So let's just do the math. On the left side, I have 5 parentheses. 2 times 4 is 8. And if you could do, like, I'm going to do this on this side too, 8 plus 3. And some of you can do this in less steps because you do some of it in your head. That's fine. 5 times 11. There we go. 55 equals 55. That's what I'm looking for, right? A number equals the same number. All right, that's first example. Let's do another one. I'm gonna go a little faster for this one. So this is example number 1. Here's example number 2. 3x plus 17 equals 6x minus 1. Okay, here we go. Look at the equation. Are there grouping symbols like parentheses or brackets? Nope. Go on to the next one. Look at each side of the equation. Are there like terms on the left side? Are there like terms on the right side? All right, on the left side, there's a term with an x and a term without an x, so those aren't like terms. And on the right side, the same. There's a term with an x and there's a term without an x, so those are also not like terms, so that's a no. Do you have variables on both sides of the equation? Well, let's see. There's an x over here and there's an x over here. Yep. Choose the variable with the smaller coefficient. Undo that variable by adding the opposite to both sides of the equation. Okay, so here the two coefficients are 3 and 6. 3 is smaller. So I'm going to subtract 3x, right, and adding the opposite, which is the same as subtracting. So this cancels. I'm left with 17 equals 6 minus 3 is 3 minus 1. Now you might look at this equation, I hope you look at this equation and you think, oh, that's a two-step equation. I don't need to continue to look at this, the foldable, in order to solve. So that's fine. Like when you get to the point where you don't need this, you just stop using it. But just to continue modeling using it for the end of this example, do you have a constant added or subtracted on both sides of the equal sign? So here I have a constant being subtracted, and so I'm going to undo it by adding the opposite, so which is the same as if this is subtracted, right? Then I'm going to do the opposite, which is added. So this cancels. I get 18 equals 3x. Again, this is a one-step equation. I hope you look at this and know how to do it, but if you need the support of the foldable, you can use it. Because I have the variable has a coefficient other than 1, right? The coefficient is 3. Undo the coefficient by doing the opposite. So this is 3 times x. I'm going to do divided by 3. Divided by 3. Okay, so I get 6 equals x. This is my answer. Okay, and I'm going to go ahead and check it really quick. I have on one side I have 3 times x plus 17, and on the other side I have 6 times x minus 1. So 3 times x is 18 plus 17. This is 36 minus 1. Oops, sorry guys. Having trouble staying on camera today. 18 plus 17 is 35. 36 minus 1 is also 35. Looks good. Alright, and we're going to do one more example. And I'm going to sort of throw everything in here in this example and make sure that we can do these really long equations, right? And it's just a matter of taking it step by step. It's not, these long equations aren't necessarily more complicated, they're just more steps, so we just have to go carefully, step by step. Okay, I'm going to keep my camera on the equation this time, and then I'm going to, as I read the foldable, right, you can just read your foldable this way. Get a little bit of a, okay, here we go. So first, I'm looking at the foldable. There are grouping symbols, so it tells me to distribute. They're not parentheses on the other side, right? There's grouping symbols here, but not on the other side. Then I'm looking at each side of the equation. Are there like terms on the left side? Yes, there are like terms here. Okay, and so I'm going to combine those. There's not a like term with 3x, right? That's separate. So 12 minus 5 is 7 equals, this has an x, and these are like terms, negative 5 plus 2. So bring down the 5x minus 3. Notice, like, this and this are like terms, but you can't combine them. You can't just combine like terms across the equal sign. So you're looking like this on one side for the equation for like terms, and then you're looking at the other side for like terms. You can't just combine like terms across the equal sign. So one side at a time for now. Do you have variables on both sides of the equal sign? Yes, I do. I have x over here and an x over here. So what I'm looking for is the smaller coefficient. This is a 3 and this is a 5. So that's the smaller coefficient. I'm going to do the opposite of that. I'm going to subtract 3x. So I get 7 equals 5x minus 3x is 2x. Okay, and then hopefully this is looking just like a two-step equation that you can just solve. And so I'm going to do that without the foldable, right? I know that I take care of subtraction first before multiplication. And then I'm going to divide by 2 on both sides, and I get 5 equals x. Okay. And I'm going to check my answer really quick. So when I check, it's 3 times 5, right? Instead of writing x, I'm writing 5. So 4 minus 5 equals 5x minus 5 plus 2. Okay. So over here I get 3, 5 plus 4 is 9, minus 5. This is 25 minus 5 plus 2. Okay. 3 times 9 is 27. 25 minus 5 is 20. 27 minus 5 is 22. 20 plus 2 is also 22. So I'm good.